Problem 2. Consider a specimen of ice that is at minus 10 degrees centigrade and 1 atmospheric pressure. Using figure 9.2, the pressure temperature phase diagram for H2O, determine the pressure to which the specimen must be raised or lowered to cause it to melt and to sublime. And then there is one more statement: at a pressure of 0.01 atmospheric, determine the melting temperature for ice and the boiling temperature for water. So the water's phase diagram can be accessed by this short URL. This is the interactive phase diagram. So this is the phase diagram of water. So let's see what we have to find. We have to find is the minus 10 degrees centigrade temperature. Minus 10 degrees centigrade. So temperature is on the x-axis. So minus 10 temperature is about here. So it's approximately 10 degrees centigrade. Minus 10 degree. It shows minus 10.1 degrees centigrade. And what has been asked is that, and at 1 atmospheric pressure, one atmospheric pressure is here. Yeah, pressure is 1 atmospheric and minus 10 degrees centigrade temperature. So we have to find the melting. Determine the pressure to which the specimen must be raised or lowered to cause it to melt. So so at this temperature, what we have to find is the pressure at which it will melt. Melt means it will change from solid to liquid state. So solid region is here, liquid region is here. So to change from the solid to liquid, so this is the temperature line, and the pressure line must be raised up to this point, okay, so that it will intersect this boundary of solid to liquid. So this is now showing a temperature of about 398 atmospheric. So the temperature must be raised up to 398 atmospheric, and then at this minus 10 degree centigrade temperature, water will convert into liquid. Ice will become into water. So the answer in here will be for this part. The answer is pressure should be 398 atmospheric. ATM. Okay, so for this one, sublime. Sublime means when we talk about sublimation, then it means that a conversion from solid to directly vapor state. Okay. So for the sublimation, we will be talking about this region, because this is the boundary. This AO boundary is about the sublimation. So here, so you can see that the temperature over here will be it's minus 10 degrees centigrade, but the pressure is approximately 0.003 atmospheric. So it's a very, very low temperature. So 0.003 atmospheric. That's the answer. 0.003 ATM, atmospheric pressure. Okay, so for this next part, at a pressure of 0.01 atmospheric, determine the melting temperature for ice. So 0.01 atmospheric. 0.01 is here. Yeah, 0.01 atmospheric. And now we have to determine the melting temperature. So melting means from solid to liquid, so we should be focusing on this BO line, B and O. So it's here. Yeah, so it is about 0.8 or about 1 degree centigrade. Okay, so you can say that this at this 0.01 very low pressure, the water will water will melt at 1 degree centigrade. 1 degree centigrade. So this one about 0.8 degree centigrade, approximately 1 degree centigrade. Okay. And the boiling temperature for this condition, boiling temperature. So boiling temperature means from liquid to vapor, liquid to vapor. So this will be the CO line, and then here you can see that, I don't know, it should be somewhere here. Yeah, it should be somewhere here. So about 16 degrees centigrade. Okay, so this is about 16 degrees. So that means at a very low pressure such as 0.01 atmospheric, the water will boil at about 16 degrees centigrade. Okay, so